All right. Okay, I think we are live now. Welcome, everybody. I'm seeing the number of participants still growing at the moment. Everything is ready. I'm Breixo Gómez. I'm the Technical Director of the European Asphalt Pavement Association, EAPA. I will be the host or the conductor of this new EAPA webinar that we have today. And as I said, everything is ready. We have our communication team already having a look at the chat, social media, and making sure that everything goes smoothly today. All the speakers are in the background, but let me tell you something. We have registrations for more than 70 countries around the world. So obviously, not everybody is from Europe. Not everybody might be familiar with the activities that we do in Europe. At the EAPA. So I would say that since the people are still arriving, why don't we just play a couple of minutes video that we have that explains very well what we do in EAPA, and then we just start straight away. Can we play the video?
90% of the total road network has an asphalt surface. There are over 4,000 production sites in Europe. Over 10,000 companies are involved, making asphalt the backbone of Europe's infrastructure. An active and influential European association is crucial to make the industry's voice heard at the European level. Since 1973, the European Asphalt Pavement Association, EAPA, has been that voice of Europe's asphalt paving industry, based in Brussels at the heart of the EU. Over the past 50 years, EAPA's voice has driven innovation, advocated for SMEs, influenced policies, and set industry standards, playing a crucial role in shaping the future of roads. EAPA's specialized committees address key issues like technical advancements, health and safety, digital transformation, leading to critical publications that inform stakeholders, influence policy, and drive growth. With national association associate members, EAPA amplifies the industry's voice through European and global collaborations and effective digital communication. EAPA's Eurasphalt and Eurobitume congresses and other events are vital for networking, knowledge exchange, and tackling industry challenges. Through dynamic campaigns, live-streamed workshops, video podcasts, and monthly newsletters, we connect our community, showcase innovations, and attract new talent to a vibrant, future-ready industry. Let's pave the way for the next 50 years together.
All right. Am I back? Waiting for my camera. Excellent. Yes, so we are back. Still trying to find, yeah. Okay. So, welcome everybody to this new EAPA webinar, this time on what we have titled Lessons and Insights from Europe's Warm Mix Asphalt Transition. So, Warm Mix Asphalt, that concept that still sounds to all of us kind of that is an innovation. We are seeing how we are pushing companies to adapt the production processes to warm mix asphalt and uptake the technologies. We are pushing the administrations to change regulations, specifications. We are seeing trial sections, test sections all over Europe. And however, let me tell you something. when the first experience with Warm Mix Asphalt were carried out in Germany, Norway, and so here in Europe, in the late 90s, so we're talking about more than 25 years ago, we didn't even have things like Google, we didn't have things like the Europe here in Europe, or we didn't, and the movie that was the big hit at the moment in theaters was Titanic. So this is how old actually Warm Mix Asphalt is. It's not an innovation, but I would like to show you this graph that comes from the asphalting figures, and that shows why are we, there we go. This is the magic of webinars. We are seeing here in blue, you see the evolution of the market share of cold mix asphalt, and in red, you see the evolution of warm mix asphalt. So as you can see, warm mix asphalt is something that was invented more than 25 years ago, but the use, at least in Europe, was very marginal, I would say. However, in the last years, we see a growth that kind of is an exponential growth. The figures are skyrocketing. This is something that we are seeing, and everybody is talking about warm mix asphalt. You can, by the way, see all these figures in the asphalting figures, the document that we publish every year. This is why we have this QR there. Now the question is why? Why are we really, why warm mix asphalt is so popular nowadays? Well, there are many reasons. Somehow the benefits or the advantages that warm mix asphalt have were not so relevant in the scenario we had 20 or 25 years ago, but suddenly have become very important with the policy that we have nowadays. For example, we have strict fumes exposure regulations in Germany, and the best way to meet the objectives is reducing temperature. We have stack emissions regulations in the Netherlands, and the same. Reducing temperature is one of the best ways that we can do that. Green public procurement systems in Norway already for many years, where companies have to compete to be greener and greener, and burning less fuel, reducing temperature is one very good way to do it. Energy costs and fuel availability. We had some issues a couple of years ago that pushed the use of warm mix asphalt also in some countries, for example, in France, because it's a way to be more independent of what can happen with the fuels. And so if we need to burn less fuel. And this we can add to many other reasons, like lower handling temperature, which is safer, short-term aging, so more durability, less thermal stress on equipment, and technology that is completely compatible with recycling and reuse of reclaimed asphalt, among others. So now I repeat the question in the other way. So if we have so many advantages, if the technology is not new and there is the will to use it, then the question is, why are we not doing it already? Why not Europe is already producing 100% of asphalt as warm mix asphalt? Well, for that, to answer that, I will try to now share my screen. Just 1 second. Let me see if I can. There we go. To give an answer to this, I think now you can. Yeah, there we go. So last year we published 2 documents, the 2 documents you see on the screen. I encourage everybody, they're available for free on the EAPA website. I encourage everybody to go there and have a look. These are documents where we try to explain what exactly is warm mix asphalt, how we define warm mix asphalt in different countries, how warm mix asphalt is produced, the technologies. What are the advantages? What are the challenges? What are the experiences we have right now with warm mix asphalt to show that it's actually not new? And we've focused the 2 documents on 2 different audiences. One is for authorities and another one more technical, let's say, for the industry. Now, this compilation of knowledge about warm mix asphalt was just the first step of a 3-step initiative. Yeah. So that was in 2024. The next step was to organize a webinar where we could learn from the countries that are ahead in this transition towards 100% warm mix asphalt, learn from them first, why are we doing this? And also, what are the challenges? So if you try to have, let's say, 100% production at warm mix asphalt, why you're not doing it yet? What are the challenges? What are the recommendations, the lessons learned that you have? So other countries that are not yet there can learn from them, can be prepared, and can make sure that they don't make the same mistakes, or they have a transition that is smoother and more efficient, I would say. The third step will be in 2026, when together with the ENE event, which is an event that we organize in EAPA with EuroBitume every 4 years, and the next one will be in June, 11-12 June 2026, we will organize a physical workshop where we will discuss in groups with activities to brainstorm and everything, what will be the future steps. So based on the knowledge we have, based on the lessons that we learned today, the next step will be defining the future. And this, we will do it in this workshop. I will tell you more about this at the end of the webinar. If you're watching this today, this is because you are here in this second step. And for that, we have an excellent panel today of speakers to talk about their respective countries. We will hear from Germany and the Netherlands, which are the countries with the most ambitious objectives regarding Warm Mix Asphalt nowadays, to talk about this, how they're transitioning the objective of producing 100% Warm Mix Asphalt for next year, 2026. And then we will have the speakers from Norway and the UK that are the countries, or among the countries with the highest production of Warm Mix Asphalt nowadays. More or less 30% of the total Warm Mix Asphalt is already being produced as Warm Mix Asphalt in Norway and the UK. Also, Norway is a country that traditionally has increased the Warm Mix Asphalt production, while in the UK we have seen a high increase in the last year. So it's also a different approach that we can compare. The program we have for today, you probably have seen it in all our communication, but something that I would like to highlight is that towards the end, we should have some time enough for quick Q&A, questions, etc. All over this webinar, please use the chat box that you have on YouTube to send your comments. If you disagree with something that some of the speakers are saying, or if you agree or you want to highlight something or add something that has not been mentioned, use the chat, please. This is the idea is to exchange, to be as to do this in the most interactive way possible. And also, if you have questions, you can post them there. But please be explicit about who is the speaker that you're addressing, or what is the country that you have some question. For example, Knut, can you explain about this? Or how is in Germany that? Because we will do all the questions at the end together. So this will simplify very much the process. All right, so that is everything I want to say. So let's enjoy. Yeah, so the first speaker that we have today, I think we have him already prepared, is Knut. I will stop sharing my screen now. There we go. And while we get Knut on the screen, I can introduce him. So Knut Johansen has been working in road construction for 25 years with extensive experience as a researcher and laboratory manager. He currently leads the Research and Technology Division at Wannsee Construction Germany. As head of German working group responsible for developing asphalt regulations, he is active driving the implementation of Warm Mix Asphalt in Germany, a task that comes with significant challenges, right? Knut, are you prepared? All right, so the floor is yours. I think you can share your slides.
Well, okay, Breixo, thank you very much for the introduction, and hello, everybody. I'm quite happy I cannot see you all, because otherwise I would have been a little bit nervous seeing several hundred people here, so I'm happy I just see my screen here. Okay, welcome everybody. As Breixo already explained, Warm Mix Asphalt is quite a big topic for us in Germany. Why is that? You might have heard that we're on the way to jump from almost nothing, so from almost 0 tons to maybe in the end 100 tons. So that's the plan actually for Germany, at least. And so what I'm telling you today is mainly based on theory, in fact. So there's not much practical experience yet. So we have a lot of test tracks, of course. I guess several hundred already, but well, it's still on the way to come. So I will give you a little bit of an overview of what we know for now, and we also have questions still. So let's see where we are at the moment. First of all, definitions. So Warm Mix Asphalt is defined a little bit different depending on how you look at it and where you look at it. And so we made a definition in our regulations, which is not yet published, but will be published soon. And the definition depends on the type of mix, on the type of binder you're using. So I tried to sketch that down a little bit, and it's quite a little bit difficult to understand, so I will explain, don't worry. So first of all, what you see on the bottom is different types of mixtures. So ACT and ACB are our base courses, so asphalt concrete as a base course, or asphalt concrete as a binder course. So binder courses are our second layer in Germany, starting at the top. So the next one, ACD, is the asphalt concrete for varying courses. And SMAD is our stone matrix asphalt, which is already used on the varying course. So what else do you see? On the line above that, you see the different types of binders. You see the penetration grade binders like 50, 70, 30, 45. And you also see polymer modified binders wherever we use them. So for example, here 25, 55, 55, which is normally only used for the binder courses. But anyway, it is used. So let's go to the graph, and you see on the y-axis here, you see the temperatures of the asphalt and well, actually I don't see that anymore. I hope you can still see that, but you've seen that there were different colors of the graph in the graph. So there's a gray color, which is the temperature range which is allowed today, and you see a green color, which is also used today and also allowed today. So gray and green is allowed today. Red is what is allowed tomorrow together with the green one. So it looks like, I'm back here. So you see the gray ones plus the green one. This is what allowed today. So example for the first one is 140 to 180. And in the future, there will only be the green and the red one. So starting at 150, going down to 130. In some cases, the difference is not that big, in fact. So we do not produce at the highest possible temperature today, okay, of course. But in some cases, there will really be a difference. So example, when you look at the binder courses, and you look for the hard PMB, which is here, then you see that we are completely out of range tomorrow. So the experience today starts at 160 degrees, and tomorrow it will end at 155 degrees. So for some cases, so like for the base courses, for example, there will be no big difference, in fact. But when you look at some other cases, there will be a big difference. So what else do we see in the graph here? When you look at it a little bit from the background, you see that there's almost a straight line through the temperature over all mixes. So nowadays, temperature is a quality indicator. Whenever you have a problem outside compacting something or working with something, you call the mixing plant and tell them, okay, I need 20 degrees more, and you get 20 degrees more. So temperature is a quality indicator still today. Tomorrow, that will not be possible anymore. We will have more or less one temperature limit over all the mixtures. So that means calling the plant, asking them to make it a little bit hotter will not be possible anymore. So we will completely change our way of looking at it. So we will have a totally different engineering task in the future. So we will have to modify compactability and workability to make these mixes being able to be paved and compacted and to work with outside in the future, although we decrease the temperature. Okay, why are we doing that? So some people say, okay, we need that to reduce CO2. In fact, that wasn't the main driver for us. So in Germany, it was different. We had a special situation. When we talk about hazardous substances, we have a designation being done by the European Parliament. It's categories which are defined according to the carcinogenity of a special substance. And bitumen was put from category 2 to category 3. In fact, it went better. But that made it necessary to define a maximum working place concentration. So you were allowed to use it, but only up to a specific limit. And in Germany, this process is started by the so-called MAC Commission, which is the Permanent Senate Commission for the Examination of Harmful Substances. They publish in German, in English, in Spanish, so everybody reads that. And they are just basing their publication on scientific studies. So what did they do? They looked in all the scientific studies and they came up with a recommendation. This is only a recommendation, but they came up with a recommendation of 1.5 milligrams per cubic meter in an 8-hour shift. So, as I said, it's a recommendation, not more, but also not less. So what is the next step? In Germany, then the federal ministry comes in place, and the federal ministry has a committee on hazardous substances. We call that AGS. And the AGS normally always takes the recommendation of this MAC Commission and puts it in place. And that's exactly what they did. They said, okay, they recommend 1.5, then we take 1.5. And we publish this 1.5. And this is more or less a law. It's something we have to apply to. So it was, in fact, already published in 2019, cited in 2020. And before that happened, we had a lot of discussions with the AGS about what is possible for us. So at that point in time, we had working place concentrations of about 15, so 10 times the 1.5. So we already addressed that to the AGS, telling them, okay, we're not really sure how to comply with 1.5 milligrams. And that was the reason I said, okay, they said to us, you will get a transition period. In that transition period, you have to find out how to comply with that. So the first transition period, which was granted to us, belonged until December of 24. And in December of 24, we gave them a report and said, okay, we gave them an extended status report and telling them, okay, we made a lot of progress, but we're not yet there. So they said, okay, we will prolong that for 2 more years. So actually, we have a prolonged transition period, which will last until the end of 26. But we're quite that's the reason, or this is the group taking care of all the homework we have to do. So let's get a step further. What were the homeworks we had to do? I will explain that a little bit better on the next slides, but one of them was implementing Warm Mix. How did we do that? So we said, okay, we will put that in our regulations, and I will tell you how far the regulations have reached already. But we said, okay, we only want to have methods which have a little bit of experience. So we are talking about roads paid for by the taxpayers. So we said, okay, we want to have a method which has a bit of experience, which has proved to be right. So these are the 4 methods which are, for the moment, allowed when we're starting with Warm Mix. So what do we have here? We have foam bitumen. Foam bitumen is quite well known, I think. So we foam the bitumen, we get a bitumen foam. We're using that as a physical modification of asphalt. We get a definitely better coating of the aggregates. We get some help with compaction due to the foam, which evaporates out of the asphalt. Second is surfactants. Surfactants, I think, are also very well known around the world, used for a long time already around the world. Not so much in Germany before, so surfactants are a totally different way of helping with compaction. And I will come also back to that a little bit later, because it has some very specific behavior. We have zeolites, which is kind of a foaming, you can say. Zeolites contain a lot of moisture, which they evaporate when getting hot. And the fourth method, maybe the best known in Germany until that day, are the waxes. The waxes are something which make the bitumen a little bit softer, which decrease the viscosity in a specific temperature range. So these are the methods which are allowed for the moment in Germany. We know there are more, but we say, okay, for the moment we want to start with that to gain experience, to see how it works, what is good, what is bad, what are the differences. As you also might know, these give different results in the end. When I use foaming or use a surfactant or zeolites, and I test for the bitumen after I paved, I get the same value as before as with the reference hot mix. When I use the wax, it's different. The wax modifies the rheology of the binder and modifies the characteristics of the binder. So we put something down in our regulations to take care of that problem. So we want that the company paving is able to choose the method. So not the client, but the company doing the job should be able to choose the method. And this is why we define something like a bitumen pair. So we say, okay, we've got a standard bitumen with foaming or surfactant, and on the other hand, we have a wax-modified bitumen, and we define bitumen pairs. So we put two of them together on the same line, saying whatever you choose, in our definition, this will be the same binder in the end. We will also have to gain experience with recycling. As you might know, we are quite good in recycling, so we have a very high recycling rate in Germany, and we don't want to lose that. So we also have to take care that whatever we get back to the plant in 10, 15, 20 years, we will be able to recycle that in the end. And there might be differences depending on the process we've got in the end. So let's go to application and compaction. As I told you, we're still a little bit on the theoretical side. We haven't done too much. So we did a lot of test tracks, of course, in Germany, but it's not like we produced 1 million tons of that, not yet. So we discussed that topic, of course, a lot. So we're discussing what might change in the future. The biggest concern for the moment is, will there be less paving days in a year? Will we have to stop paving earlier in the year? So nowadays we pave up to December if possible. Will that change in the future? Will we have to take care of the temperatures outside a little bit more than before? On the other hand, will there be a smaller compaction window on site, which might result in having more rollers outside, having maybe also different rollers? So does that make paving more expensive in the end because I need more equipment on site? Also, how should I use my rollers on site? What about shorter compaction lanes? Do I have to be closer to the paver? Does that impact my safety concerns on site? So a lot of questions we're asking ourselves, and I can't yet give you the whole answer. I'm quite sure that it will also depend on the process we're using. Every process I showed you is different, and so every process has to be dealt with in a different way. We already have experience, for example, with surfactants. Surfactants, for example, do not change the rheology of the binder. So whenever the mixture was delivered to the site and it was 30 degrees colder than before, the people working on the paver who worked there for 20, 30 years said, oh, this is too cold. This is what they call dead hot mix. And so they started compacting like hell and directly behind the paver, which ruined the evenness in the end. Surfactants work but only when they get shear forces at the screed or under the roller. So you do not really see that, you cannot feel it. That's what I want to say, when often field experience will fail in the future. So we will have to train the people outside. They have to know which method is used at that very moment. And they have to take care. And it's a different way of dealing with the method and compared to the other one. Okay, so what else? Workability and compaction. So compactability is a different thing than workability, of course, and I think we will address the topic again in the next presentations. But compactability, we are still testing with the Marshall device in Germany. So we have a kind of compaction device which is not really able to identify or to simulate the effect of some of the methods in the laboratory. So we actually have a problem simulating how much temperature do we gain, how much of the time window do we still have when we just do that in the laboratory. So we need to have more experience on site. We do not use the PCG, which might give you a deeper insight, and I hope that we will get new testing methods in the future. This is one thing that really annoys me a lot. We're still using penetration, we're using softening point, we're using Marshall, which are all more than 100 years old. So we will have to definitely change the way of testing and simulating it. Same as for workability. For the moment, there's nothing, not even an old method for workability. So we are thinking about maybe using that NIAS device for looking at workability. So trying to help the people who work by hand with the asphalt in the future. So this is still things we will have to figure out in the future. Okay, just one look at health and safety. So health and safety actually is the driver in Germany, and you might have heard about this stop mechanism. So we have to start with substitution whenever we have a problem. For the moment, we don't see one. Then we have the technical things. And this is what I wanted to show you. So we're not only doing Warm Mix. Warm Mix is one of the technical things we're doing, but one of the other main issues is for us the paver exhaust systems or ventilation systems, as they're sometimes called. So we already have a second generation on the market thanks to the equipment producers. And so only the combination of these two can help us in the end to reach this 1.5 milligrams per cubic meter. So just to give you that it's not only Warm Mix Asphalt, we will also have to deal with equipment in the end. I told you that we will have to implement the Warm Mix in our regulations. That was one thing we promised the AGS. So we said, okay, we will definitely put that in our regulations. And you see that we are actually we have proceeded very far with our new regulations for production and for paving. And we're sure that we will get them out in the first quarter of the next year. So from that day on, our regulations will be 100% Warm Mix. And well, I'm still a little bit nervous about that big step, but I'm sure we'll get it done. So we will have also different characteristics for our layers. So when we publish these new standards, and we will have Warm Mix 100%, at the same moment, we're dealing with different characteristics of our mixes. So this is an example here. This is a stone matrix layer, stone matrix asphalt for the second layers, for a binder layer. And what you see here, that is, we have a compaction degree, which is compared to the Marshall compaction we get in the laboratory. So we have to have on site in the layer 98% of the compaction we got in the laboratory. So I told you that with the Marshall compaction, we're having trouble getting the same effect which we get outside. So some of the methods we use for Warm Mix will not be so dominant in the laboratory too. So we might not see that effect in the laboratory. So at the same moment, we will get a problem outside when testing after we paved. So there will be probably a lot of discussions. At least we will now have the void content, not only for the top layer, but also for the other layers in Germany. So that might help in the discussion so that we will, when we have trouble with the compaction degree, we might get back to the void content, because the void content is really what tells you the truth of what has happened. Okay, so just some lessons learned in the end. Most people in the German asphalt industry are not only skeptical, They are really masters in ignoring something. So we have gone out, we made roadshows with the German Asphalt Association. We addressed more than 900 people about the topic. We told them this will come, please prepare for it. I just did a seminar 2 weeks ago, and still people asking me, are you sure this will come? And yes, it will come. And I think everybody should be open to innovation. So the biggest mistake we made in Germany is that we called it Warm Mix Asphalt. I think we should have gone with the name asphalt, as it's still asphalt. It just has a different temperature table in our regulations. If we hadn't told that to the people, they wouldn't have even realized that. So I think in the future, whenever we take the next step to whatever it is, code or whatever, I think we will rename it. We will not rename it. We will still call it asphalt. That makes it much more easier for us. And the last thing, change is possible, which gives us all hope, I think. Sometimes we need to be forced into it. This is what happened in Germany due to our sanitary regulations, but I'm quite happy about it now. Okay, thank you very much so far. Pleasure, I give the word back to you.
Yes, so unfortunately, Knut, we lost your connection for a couple of times, a few seconds. It was when you realized about the slides. I think in general, it was just a few seconds. But for the people online, I must apologize about that. What I'm seeing is that some people even suggesting that this is a recorded event. So I think this is part of the proof that is that is live. In fact, I don't know if we can bring all the speakers to show you that actually they're all here to answer all your questions and to respond to all your comments. So we're here. All right. Thank you, Knut. I think it's very interesting what you say about for how long we will have to say warm or hot anyway, right? We have to change this mindset about the temperature. There are many things that we don't say about the mixes. So why in the temperature anymore? This is a proxy for quality that we don't need anymore. So it's very interesting. And I also share with you what you say. I'm nervous about that. So we'll see what happens in Germany. We are all looking at you. All right, so, okay, we can continue talking about that later on during the Q&A. So for the sake of time, I would like to introduce our next speaker. From the Netherlands, she is Tessa Leyendijk. I think I pronounced it correctly. She leads the innovation and sustainability at the province of South Holland. It's a government, part of the government, where she coordinates the region's infra innovation strategy and works to establish sustainability into projects and policy. With a background in civil engineering and extensive experience in asset management and sustainable road construction, she focuses on themes such as CO2 reduction, circularity, and energy efficiency. Tessa is passionate about accelerating the transition towards more sustainable infrastructure through collaboration, innovation, and practical solutions, including the implementation of Warm Mix Asphalt. This is why you're here. Thank you very much, Tessa, for being here, accepting this invitation, and the floor is yours.
Thank you. Hello, everyone. Yeah, so I'm a sustainable infrastructure coordinator at the province of South Holland. For my foreign colleagues, a province in the Netherlands is a regional level of government between the national and local levels. And today I'm proud to share how the Netherlands is transitioning from hot mix asphalt to warm mix asphalt, starting with how we approach the transition, followed by some challenges and the lessons we've learned along the way. Like you already mentioned, warm mix asphalt is not new, also not in the Netherlands. In fact, we also have over 25 years of experience developing and applying warm mix asphalt. And just like in your countries, our goal is clear. We want a climate neutral and circular infrastructure by 2050. And to accelerate this transition, the Dutch asphalt industry took a bold step in 2022, announcing that from 2025, so this year, hot mix asphalt will no longer be available and warm mix asphalt will become the new standards. And although the many years of experience, it did come as an enormous surprise and felt as a complete new innovation to many government parties. But gladly, the initiative was quickly embraced by the national government called Rijkswaterstaat in which offered its full support to make this transition a success. And that collaboration became the foundation of our approach. And to make this transition work, we set up a national working group with representatives from all sides, like national government, provinces, municipalities, but also producers, contractors, and suppliers. And we started by defining the scope, covering the relevant mixtures and techniques. Then we assessed the maturity of each technique using a combination of theoretical tests, research data, empirical evidence, and practical experience. And this approach ensured that our evaluations were both scientifically sound and also practically applicable. And all this gathered information were combined into a guideline, whereby the draft was also shared nationwide to secure a broad support and alignment across the sector. And while I'm sharing this quite easily right now, this process took actually over a year, with meetings in groups from 20 to 25 persons and meetings every 3 weeks or more often. But if you ask me, it did end in a clear and practical document, which is published by October 2024, so a bit more than 1 year since now. And with this guideline, we wanted to provide clarity to clients and contractors about which asphalt mixture with which techniques can be offered as Warm Mix Asphalt. We wanted to create confidence among clients that the approved Warm Mix Asphalt mixtures and techniques are truly equivalent to the standard hot mix asphalt mixtures. And with the guideline, we provide supplements to the standard requirements specifically for Warm Mix Asphalt, whereby we offer it as a tool for clients and contractors to manage any Warm Mix Asphalt risks as much as possible, in the hope we can accelerate the transition to 100% Warm Mix Asphalt, whereby taking this step with this transition towards a sustainable infrastructure was the biggest driver to want to make this all a success. So this guideline ended up as a physical bookwork with 3 chapters and several annexes. It explains in general what Warm Mix Asphalt is and frames the outline in which the document operates. But it also delves deeper into the technical aspects and provides recommendations for its application. Then we have some annexes that goes deeper into various aspects of the general chapters, and 4 annexes that address each one specific technique in more detail. And the best part, next to that it is a physical document, it is free to download online. The link is below, but it is in Dutch and non-searchable. But if you want to read it, it's free. And in the context of communication, it is important that we are all sharing the same understanding. Therefore, the guideline also contains a list of definitions in which the following definition is used for Warm Mix Asphalt. What is asphalt that is produced at a temperature between 100 and 140 degrees Celsius, with the note that that's the temperature at which the mixture leaves the tank. So it can be that some of the raw materials can be preheated above or below this 140 degrees Celsius. And in our guideline, there are currently 4 approved techniques, which are standard foaming, optimized foaming, which is called layup, which stands for low emission asphalt concrete, and 2 types of additives. One type of additives that reduces the surface tension, and the other one that reduces the viscosity of the bitumen temporarily. There are 2 caveats to this. In this case, approved means that it has passed the entire assessment within the broad working group to prove its maturity, as I mentioned before. And although the guideline is not an official regulation, it does ensure quality and avoids unnecessary risks all because of the strict assessments we did. This does not mean that any other technique which is not in the guideline at this moment is bad or will never make it to the document at all. The second caveat is that regarding the additives, that the ones are mentioned in this presentation are the ones that are approved according to the guideline at this moment as well. And to increase the quantity of the type of additives, the working group also has set up a process that allows suppliers of other additives to demonstrate the equivalence to the current additives, and if successful, these also will be included in the guideline. And to give you an idea of the spread of the different techniques I just named, in our province, the road maintenance is divided among 4 contractors, whereby each contractor could choose their preferred technique, and every contractor actually chose a different technique, which means that all 4 approved techniques are being applied in our area. And to be honest, I don't think that is a coincidence, but says something about the popularity of the different techniques. And during the assessment, we not only assess the techniques in general, but also specifically per type of asphalt. Thereby, we adopted our standard asphalt mixtures, which is asphalt concrete for surf, base, and bind layers, stone mastic asphalt, porous asphalt, and noise-reducing asphalt. And again, we assessed it based on fundamental theoretical tests, functional research data, empirical evidence, and practical assessments, which resulted in this matrix, where green means it was found to be equivalent to hot mix asphalt, and if not, the box is red. And with all this, we wanted to create confidence among clients that we are not taking this transition lightly, but that it consists of well-considered choices based on quite heavy assessments. But as if that was not enough, we, the clients, wanted even more certainty. Not this time about the quality of warm mix asphalt in general, but whether if every asphalt plant could produce it and every contractor could apply it. So to increase the client's confidence, a separate program was set up in which every asphalt producer can demonstrate their ability to deliver a high-quality warm mix asphalt, and the contractor can demonstrate their ability to apply it, whereby every test section is subject to independent and expert supervision, and all results are made public. Also, extra examples will be taken for extensive testing that, for example, it has no adverse on health, safety, and environmental effects, long-term empirical and functional properties, and the recyclability of the asphalt mixture, but also that it is compatible with other common additives and bitumen in case that these come into contact to each other during the application of reclaimed asphalt. And if you want to read more about this program, you can again click on the link below. And in this case, it is a website, so I think it can be translated to English or any other language. And like I mentioned before, we also examined the potential risks associated with warm mix asphalt. And we quickly concluded that many of the risks are not exclusive to warm mix asphalt, but are also applicable to hot mix asphalt. However, existing risk may occur more rapidly and intensify in the case of warm mix asphalt due to accumulation of multiple risk factors. Therefore, the guideline includes a comprehensive list of identified risks accompanied by corresponding measures designed to minimize and control the likelihood of their occurrence as much as possible. And this list of control measures is based on best practices at various phases from design and planning up to processing the warm mix asphalt. And this not only helps mitigating risks, but also in taking away certain fears, mostly around clients about warm mix asphalt. And some best practices per phase are like in design and planning, you can minimize obstacles and manual work. It's good to take the season, so it's good to take the weather into account. Keep it in mind when you're planning, but also bring contracts to the market in a timely manner, and therefore prepare them in a timely manner. A producer, for example, can draw up a production specification for the Warm Mix Asphalt mixture, including additional checks, so they are sure the production goes well. But they also can draw up a processing instruction in consultation with the contractor, so the contractor knows how to compact the specific asphalt mixture in the right way. About transport, well, due to the smaller temperature difference with the surrounding area, warm mix asphalt cools less quickly than hot mix asphalt, providing greater logistical flexibility. However, local cooling remains a risk, and therefore isolated transport is crucial. And the use of asphalt trailers with moving floors can help to minimize cooling and segregation during unloading. It also may be necessary to increase the production temperature by a few degrees, of course, up to a maximum of 140 degrees Celsius. And the use of digital systems to coordinate the processing speed of the spreading machine combined with the transport of the logistics is recommended because it prevents downtime of the spreading machine. About processing, for both hot mix asphalt and warm mix asphalt, processing is crucial for achieving the final quality in practice. And some general control measures can be like preventing residual moisture on the subsurface before applying warm mix asphalt. It's good to keep a constant speed of the spreading machine and mostly avoid downtime. But most important, I think, are the rollers. They need to be heavy enough to be able to compact the right way, or you can maybe even think about adding an extra roller. And also the rollers should be more close to the spreading machine, whereby they also have to prioritize compaction of seams and joints. And when hearing all this, you might think, sounds good, they'll manage just fine. Well, we hoped the same ourselves last year. We have a national agreement for the standardization of warm mix asphalt. It is supported by a widely endorsed guideline, which I just talked about. And again, there is a lot of experience among producers, contractors, and clients with warm mix asphalt. Why is it not yet 100%? If you ask me, warm mix asphalt is not merely a technical change. It also requires adjustments on administrative, cultural, and economical levels. For example, some technical barriers are that not all asphalt plants are yet fully equipped for production or on lower temperatures at this moment. But also the viability of mixtures is causing trouble. The Dutch market has an absurd wide range of asphalt mixtures, whereby none of them behaves identically when produced as warm mix asphalt, which increases the need for type testing and validation. If you look at the administrative and organizational barriers, is that many existing specification and contracts still prescribe or refer to hot mix asphalt. Amending these require procurement and adaptation, while no single national enforcement ensures that hot mix asphalt is banned at this moment, what means that adoption of warm mix asphalt relies on a voluntary base. With that, most of the local authorities are waiting for national obligation or sector-wide conviction before changing their policy. Where we now, I think we come to what is the biggest challenge in the Netherlands, which is the cultural aspect. Like Knut already said, is the same for the Netherlands. Us Dutch authorities are known for cautious innovation adoption. Even with proven pilots, we keep on saying what we know works. Why would we change that? We still want to see long-term performances and stay cautious without multi-year monitoring results, but also due to the high workload, we don't have the time to gather more information about existing and proven innovations. What results in that we most don't know is that warm mix asphalt is already proven and contributes to a sustainable infrastructure. And beside that, we find new things scary. A lot of authorities live with the idea that implementing warm mix asphalt is very complicated, which is not. And last but not least, there always will be economical barriers. Modifying asphalt plants involves capital expenditure, and to recoup these investments, warm mix asphalt will cost slightly more. This also shies away clients as well, forgetting that this is only temporary and forgetting the benefits, the environmental benefits of warm mix asphalt. And having mentioned these barriers, I think these challenges do slow things down, but they are not showstoppers, and therefore we need enablers. So reaching 100% warm mix asphalt is not just a technical change. At this moment, if you ask me, it's mostly a cultural one. Again, reaching 100% warm mix asphalt requires vision, collaboration, and bold action. Thereby, enablers play a vital role by taking risks, inspire others, and provide the proof that warm mix asphalt works in practice, which builds trust among the people that are not convinced yet. It is about collective effort whereby producers, contractors, road authorities, and policymakers must work hand in hand, sharing knowledge, solving problems, and celebrating successes, because every lesson learned, every challenge overcome brings the sector one step closer to full adoption. In my opinion, warm mix asphalt is 100% achievable. And although the official target of January 1 this year was not fully reached in the Netherlands, progress is happening every single day. In the Netherlands, this is the first major transition, but it certainly will not be the last. Warm mix asphalt alone will not deliver the climate neutral and circular infrastructure we want, yet the lessons, collaborations, and momentum gained from this transition will determine the success of the many transformations still to come. Although we have not reached full implementation, we are making steady progress and learning lessons every day, whereby, if you ask me, the biggest lesson we have learned is that none of this will work without open and transparent interaction among all stakeholders. And that's why I think this webinar is an amazing initiative. And I would like to thank you all for listening. If you would like to learn more about our guideline or want to connect with me, you can reach me via email or LinkedIn. And I will say, let's keep working together, building a truly sustainable road network people are relying on. Thank you very much.
All right, thank you, Tessa, for this very interesting presentation. I think we all appreciate all these efforts to create reliability and credibility to this. It's not an innovation, as I said before. It's something that we have there for 25 years, and still we're working on creating all these reliability. But I think the efforts are very appreciated. And you said that you believe that this 100% is feasible. I'm curious, maybe we can talk more about that. When you heard first from the industry of this target, what was the reaction from the government? So you think now you're saying that you believe on it, but I don't know if at the beginning all the government was on board, administrations and so, or it was a bit of conflict there. Maybe we can talk, hold on, because I'm actually seeing a lot of questions and comments in the chat. I love that. So we'll see how long we have at the end for all these questions. For now, thank you very much, Tessa. And I would like to introduce our next speaker that comes from Norway. Here's Geir Lange. Geir, are you there? Geir has been working with asphalt for more than 30 years. First with the Norwegian Aviation Administration with runway projects in Norway. And from 2010 with Veidekke, Norway's largest asphalt contractor. The past 12 years also as EBA, the Norwegian Asphalt Contractors Association, representative in the various EAPA's committees and task forces. Actually, Geir is one of our most active members, and we thank you from EAPA, Geir, in advance also for being here today. So Geir, the floor is yours. Tell us what is going on in Norway.
Thank you, Bertram. Thank you. Hello, everyone, and thank you, Breixo, for the introduction. What's going on in Norway? It's been going on for many years, and it's always funny to see the picture from Norway in 1995 explaining Warm Mix Asphalt. So I had to have it in my presentation also today. But anyway, we have Norway, just a little bit explanation. EBA, the Contractor Association, has 11 members, asphalt producers. There's a total of 13 in Norway. The EBA members are producing more than 95% of total production in Norway. And 4 of these members, they produce more than 40% Warm Mix Asphalt last year. Another small thing is that in Norway there is a lot of ship freight for asphalt along the coast. So it's around 20% of the total production of asphalt is hauled by ship. So that's one key and one lesson learned we have later here in this presentation. I have to thank the other companies, members, Feiring and NCC and PIAB for input to this lesson learned, and this might be a little bit more or just experience we have had now for the last 14 years on different plants, different mixes, and a lot of problem. It's not that problematic with Warm Mix, but we all have on each plant some various problem or one problem that occur on 3 plants or whatever. So first, the definitions. We started in 1995 with this famous picture where the aim was to reduce the temperature with more than 50 degrees. We call it warm asphalt mix, WMA foam, which was the first product, and we have 2 plants in Norway in 1995 producing this. Since 2012, EBA and the Road Administration and the government would like to push the Warm Mix production. And in this cooperation we had with the Road Administration, there was a situation with a bonus if we produce Warm Mix Asphalt in contracts. The requirement was that it had to be more than 25 degrees reduction, and based on some tests we did the year before, we had to use the foaming technique. So that was the first years, and then since 2019 we have used the the EAPA definition that we have to reduce the temperature with more than 20 degrees. And as Knut mentioned earlier, there's a lot of mixes, a lot of bitumen types and everything, so it's not one set fixed temperature. The total production in Norway is the blue around 6 million, 7 million tons it has been, and now past last year it was just below 6 million tons. And the percentage of Warm Mix Asphalt for the total production is the green line showed here. And why the increase in the first 3 years? That was due to the bonus system from the Road Administration. So that was really a push for that all the contractor could translate to Warm Mix production with the foaming system. Then we had also the discussion with the Labor Inspector Authority in Norway that they also want to push this, and they require that EBA had to report percentage of Warm Mix Asphalt each year, and it had to increase. And the aim we had back then was to reach 40% Warm Mix Asphalt around these times in the just after 2020. So something happened in 21 with the pandemic and everything, and now it started increasing again. So And as mentioned, 1 million ton about was the last year's volume of ship transport with warm mix asphalt or hot mix. Drivers, as you asked for, Breixo, it's major the fume exposure, and in EAPA on several committee meetings we have had this discussion about how to measure the fumes, which system or which requirement to use. Is they similar? But anyway, we have done a lot of tests in Norway with the Occupational Health Agency, and that started in 2011 when we tried. We had 11 different test track with foaming techniques and 5 different additives. And based on this test, it was introduced a foaming system that would give the bonus we have. Then we have had several testing by on paving site, both with ship, freight, with PMB, with different type of PMB, in inside tunnels, and in 2022 we also did a huge test for the health of the workers before season started and mid-season in July. Those results will be finalized, I think, early next year, we hope. It's a PhD study going on with all the results, so hopefully there will be some. So what we have done since the bonus system was introduced in 2012, nearly all the plants have foaming system. So that's the experience. And as Tessa and Knut said, Warm Mix Asphalt works, but it's always a complaint when you have a handling or handling. And some of these tests we have done with, they have in the report that there is no significant difference with warm mix and hot mix asphalt, but that can change the attitude for a lot of people. So smaller contractor that just buy asphalt from a plant, they order a really hot asphalt or sparkling asphalt, as I have heard from UK. So, and all this discussion, it's always an argument why it doesn't work, but it can be a lot of things. So it's not one thing in each plant or maybe each country or whatever. So, and that's the same with hot mix asphalt. You may have difficulties or some failure with something. It's not maybe not the hot mix asphalt. It's the production or all the other thing in the paving line. Contractors in Norway, we are free to use warm mix asphalt. There's no limitation or anything in the guidelines. Some counties in the northern part has required 60 or 70% warm mix asphalt in their paving contract earlier years to increase the volume, and that's good. What we have in our specification in Norway is the minimum temperature on the paving sites. So that's these two tables here are, I think it's from the EAPA document, but that shows for paving grade bitumen and PMB bitumen. And same as Knut showed, it differ for each binder grade. So we use more softer grade in Norway and not in Norway, but anyway, so this is the limit we have from as contractors. Just one example, let's discuss the paving and paving window and everything. What we see when we use infrared cameras behind the paver, it's easier to have a homogeneous temperature on the mix at the site with warm mix asphalt. And yes, it's you have a larger compaction window to increase or to achieve the right air void. And all this ups and down here, that's either a roller or a person going into the infrared scanning. So this is from the same plant, same mix, but warm and hot mix asphalt. Logistics, that's another thing. As I mentioned, all this ship freight with asphalt have had some problem on some asphalt plant. It depends on the storage capacity at the plant. If it takes a long time to load a ship with 1,000 ton or 1,300 ton or 800 tons, then something will happen to the mix. So that's not preferable. So if you have the right silo capacity and loading system, then it works quite well. And on smaller plant where you don't have this a lot of loading system, then they often choose hot mix instead of warm mix. So that's one of the drawback with ship freight. But also we have tried some years ago in 2017 or 18, we sent some ships to Spitsbergen, and that 48-hour sailing with warm mix asphalt, and it works quite well when we pave it. So the paving team do very much like the warm mix asphalt when we send it that distance. So I don't think you have to do that in the rest of Europe, but anyway. And lesson learned, that's just a disclaimer or what to say. As I mentioned, we have a lot of the foaming system. And we had to construct our own foaming system in the plant when we started in 2011, 12, 13. So when I've collected this experience or lesson learned, it's not due to the asphalt plant manufacturer. So bear with me. We have produced or built this system as for our own and introduced them to an existing plant. So it's not a plant manufacturer thing, but it's experience we have achieved around Norway. So the foaming system itself, the major rule is that no plant is equal. There is no plug and play and get warm mix asphalt out. You need to adjust the plant, you need to adjust the water percentage to get the right foaming, you need to adjust the pressure, and also you need some types of pump, some other type doesn't work. So it's like actually you have to learn how your plant is working with your mix and your reclaimed asphalt percentage and your everything. So and when using the foaming system with water, you also need to check the quality of the foam. The left picture here is a foaming sample that actually doesn't expand. It just bubbles in the bottom of the barrel, which this other one that works quite well, that got this expansion of the bitumen and the foaming in the mixer. So if you struggle with warm mix asphalt production with foaming, then maybe the reason is because the foaming system doesn't work quite sufficient, or the water percentage is too low or whatever. So you have to address each plant separately. So the other thing that may have stopped or caused some problem is that when you produce warm mix asphalt and some other will like a hot mix asphalt in the plant, and the next customer will have warm mix, you get a very much up and down temperature in the mix. This is an old picture from a temperature at the mixer, but here I just took out the warm mix asphalt production during a day, and when you see you have an increase in temperature, that's due to you have a hot mix asphalt just prior to the warm mix asphalt recipe. So why not 100% warm mix? Because then you have a more stable temperature in the plant. The other result is that everybody complain on the mix, both the hot mix and warm mix, when you have these changes. That's not rocket science, but it's a thing to remember. So I think this is maybe one of the main reasons why we got a bad reputation for Warm Mix Asphalt, and also some people really don't want to produce it. So on the other side, with all the other thing, that was just a foaming system, but also various binder may have different foaming properties. Sometimes it doesn't work, some other times it works. You get some, you have to adjust the temperature in the filter when you produce with the foaming system. Mixing time, some of the plants I've talked to and companies I talked to do have some problem with the mixing time. They have to increase the mixing time, hence the production capacity of the plant go down, and then you start a discussion of how much do you have to produce. The other thing we have seen, and all of the companies have seen somewhere, is that you may get the evaporation or the foaming that they create some clogging in the silo or in the tower of the plant. Can be adjusted, but it's an initial problem you have before you have adjusted your plant. And also within the mixer itself, it can be some clogging. Not every day, but over time. So the other thing is that we have, you saw the increase in Warm Mix Asphalt and a small drop 2-3 years ago. And that's also maybe due to the percentage of reclaimed asphalt that we use in Norway. That has been for many years not on the level as Germany or Holland or UK, but now it starts to increase. And then when we have less virgin binder to foam, the foaming itself will be different. So that leads to some problem in some plants. And some of the comment I received was that instead of foaming, when you have a high amount of reclaimed asphalt, we use additives instead of foaming to lower the temperature. Why not 100%? This is just the red line is the mean temperature each month in the Oslo area. When we have the foaming system and the water added, we stop the system when the temperature drop below 0 or freezing. So in the autumn, now I think we have stopped on all our plants foaming or warm mix asphalt, and the same during winter. So from April to October, we produce warm mix asphalt with the foaming. The other thing, why not? It's attitude, culture, as both Tessa and Knut said. And also the know-how at each plant. That's quite important. You can't just plug and play and start produce it. And I think one of the best examples is that yes, we can produce warm mix asphalt at least 90% or 100, but this is 4 design and build operate contracts that's opened in Norway the past 5 years, and here the contractor has the responsible for the mix, and we have chosen to use warm mix asphalt. And this is 2 different asphalt producers, so it's not just one. So that's and still it works quite well. So shouldn't be any problem, I think. So that's about it, Breixo. Hope the sound was okay and some input.
These technical inputs. In fact, I think it's very important what you mentioned, no? The know-how. And I remember from conversations with Gary in our committees and so that sometimes it happens that there is an asphalt manager saying with the local materials we have it's impossible, it cannot happen. And then some other manager comes from a different plant and spends some time there, and at some point it works. So it's a lot about the know-how. As you said, we can't just come, plug it, and start producing. It has it requires some adaptation. We have, in fact, some questions about the adaptation. Also, what you mentioned, and we will come back to this point later.
Sure.
Please keep asking questions and comments. There is an excellent debate right now in the chat with a lot of questions, and I think we will have to spend even a few minutes the webinar to deal with all these questions. So this is great news. Please continue like that for all the audience. Thank you, Ger, and see you in a few minutes.
Yeah.
Right. So with this, we move to the next speaker. Coming from the UK, Malcolm Sims. Malcolm studied civil engineering at Dundee University and began his career working on major infrastructure projects before moving from site engineering to materials testing and technical roles within Mineral Products Association member companies. Joined the Quarry Products Association in the year 2000 and became director of WMA Asphalt in 2011. He's active in technical, political, and policy aspects of asphalt and pavements through MPA, EPA, EAPA, PSI, and SAN committees, and is a regular media spokesperson for the Asphalt Industry Alliance and active participant in numerous EAPA events, congresses, etc. Again, as I said before, for Geert and Knut, Malcolm is also very, very active members in every committee and task force that we have in EAPA. He also has some awards in EAPA. He was granted with the Asphalt Advocate Award in the year 2020 and the EAPA Technical Excellence Award in 2022, and also he is the IAT Honorary Fellowship from last year, 2024. Malcolm, thank you for participating, and we are looking forward to learn more from UK.
Thanks, Breixo. Always a pleasure, as you say, to contribute to the EAPA activity, and just looking at the chat and the global audience we've got, I think it's a great initiative we've put on today. Luckily, those of you that do know me, I tend to speak for too long and have too many slides. Luckily, a lot of what I'm covered has already been covered by the other speakers, so that should help me rattle through things a bit more quickly. So let's go. Warm Mix, it's, as Breixo said in the introduction, it's not an innovation, it's a journey. I was involved with the EAPA position paper back in 2010. I convened a session at the E&E Congress in Istanbul on Warm Mix in 2012. Within the UK and our association and other partners, we've been doing collaborative research. That report is from 2013-14. And obviously presenting outputs from research and events and all sorts of things. A lot of what I'm doing today is borrowed from other presentations that I've given in the past. Just like asphalt, most of my presentations are recyclable. In particular, was one that we produced in 2016 for a Highways UK event, where we produced a promotional video, which is also shared widely in the UK. So if you see the little movie camera shot there, that's taken from our video, and right at the end we'll get a link to that video. Right, so looking at the drivers first. For the UK, the primary driver for Warm Mix is decarbonisation. We got drivers from the very top of government, so that's a report position statement from the Department for Transport. They look after everything, road, rail, whatever. So they've got a decarbonisation agenda. That translated into our National Highways Authority, called National Highways. And with them, we worked on developing what they call their 20, 30, 40, 50 plan. So setting milestones for those dates in the future of their decarbonisation journey and progress. And this is the sort of thing you see across the world and across Europe of waterfall graph suggesting the degree of decarbonisation that will happen in various timescales. You'll see the error bars on each of those blocks. So the further into the future we look, the more uncertain we are about what level of reductions we may achieve. but it still helps us set a trajectory. At the end of the day, we're looking to get to net zero by 2040 in the UK. Important to note that while decarbonisation is a driver, we will not achieve decarbonisation or net zero by warm mix alone. Again, from another presentation at an event, this was the list we agreed with National Highways of levers to get to decarbonisation, net zero. Optimised use of warm mix was right at the very top. So if we ever needed a driver, there's an example of it. Other items in there: recycled, lower carbon plant, reduce the moisture in aggregates. You don't have to put in as much energy to get the water out. Let's look at asset management as well, how we look after the roads once we build them. And then other things, specific optimization on sites. Nobody has actually mentioned so far reducing bitumen carbon emissions. The asphalt, majority of the carbon in asphalt comes from the bitumen and from our drying activities. So we need to look at those things in combination. And reducing temperature is just the start of all of that. So we were asked to provide a definition for warm mix. Again, from another recycled presentation, what is it? I think it's clear from what we've seen already that warm mix, a lot of people, when they heard the terminology, thought it was a single thing. It was a single mixture or product type. It's not. It's a range. It's generic terminology to indicate a production temperature reduction for whatever asphalt type you're making. It is just by a lower temperature methodology. And that can be processed methodologies like foaming, we've heard, or additives. Again, in the pictures there we have our zeolites, there we have our chemical additives, and all of these can be embedded in our bitumen phase as well. So it's not a single thing, it's a range. But otherwise, everything else about warm mix is pretty much the same. It is only the temperature that's the defining difference. So how do we achieve temperature reduction? There's a snapshot from our video. Stress again, achieved with a range of foaming and additive technologies, and you get reductions of up to 40 degrees, lower than hot mix. As with Norway, we follow the EAPA definition of 20 Kelvin, 20 C reduction is a part of the definition. How do we control it? Well, within the UK, we have what we call national application documents or published documents issued by British Standards Institute. And the latest one of those in terms of production of mixtures as a guidance document was revised and published in 2022. And this is a direct copy from that document. So since the previous edition, routine use of warm mix asphalt has become established in the UK. The available manufacturing technologies allow the production of asphalt at lower temperatures whilst enabling normal compaction on site. The range of technologies available for warm mix asphalt production means that guidance on minimum and maximum temperatures should come from the manufacturer and should be declared and documented by the manufacturer. That ties in with your obligations on CE marking, UK CA marking we have, but the onus on declaring temperature lies with the producer. And all that feeds into your Part 21 factory production control systems as well. Again, another snapshot from our video on application and compaction. One of the benefits that we identified with warm mix in the early days, limited production plant modification is required depending what technology you choose to deploy, and it can be laid using existing equipment. So again, that should all be relatively attractive for producers, that they don't have to fundamentally change all of their processes. How do we control workability and compaction? How do we test for them? I suspect this will be a topic for discussion later. Again, from BSI, we have an application standard, BS 594987, and that was revised and published at the end of 2024. This sets out the requirements, the specification for transport lane, compaction, and also how we address type testing, actually. Within that standard, I know that's probably very small for everyone. In the 2024 revision, we were able, or we decided to include warm mix asphalt temperatures. So down the left here, you have a range of product types, binder grades, and the comparative hot and warm discharge and compaction temperatures. So that was how we set it out, and these are for average run-of-the-mill products, non-performance based product types. We specify the temperature. Lots of things we don't include. Hot rolled asphalt, we haven't quite mastered warm mix, hot mix asphalt or hot rolled asphalt. The clue's probably in the name there, but they're really workable mixtures, so compaction isn't the same issue. In general, again, we're looking at that 20-degree reduction compared to hot mix. As I said, for method compaction, everything's the same, and in terms of end production compaction products, we also have to comply with the density, air voids, and everything else we would test in situ. So we're saying an alignment on what we need to assess, and for a number of materials, we provide that guidance on what that temperature needs to be. Health and safety, another comparator similar to what Gare showed. These two pictures were taken on the same day, on the same site, with the same equipment. You can guess the one on the left is hot mix, and the one on the right is warm mix. If ever you needed a visualization of fume reduction through warm mix, I think that's it. We haven't been over-regulated on health and safety thus far, but it's something we continually keep an eye on. But it is a benefit that we recognise that comes from warm mix. So what degree of success have we had with it? This press release came from the government, UK government, in August 2021, announcing that Highways England, as it was then known, had accelerated its switch to lower carbon asphalts by adopting warm mix asphalts by default as their preferred mixture types. And what did that mean in terms of national specification? So before before last month, our specification looked like that in relation to warm mix. There was a list of permitted mixtures, and only those mixtures could be produced on a contractual basis using warm mix. So we got 7 product types there, and the compliance requirement on temperature was then defined against the paving grade as used in each of those product types. So you had 7 product types and the variables on paving grade. So straight run, penetration grade binders, maximum temperature 150, hard paving grade binder 160, and interestingly on polymer modified, that was still permissible to use with a producer's declaration as long as it showed a temperature reduction. as I just said, the national specifications were changed at the end of last month. So the approach on Warm Mix and the whole standards specification has changed to focus more on individual product type sections, but they still have the same requirements. So in our base course materials, they see an AC32 with the 4060 pen binder. We have to also include a designation W to indicate that that is using a warm mix technology, any warm mix technology, just that it is there. And again, for that same material, maximum production temperature 150 degrees C. Then for an EME2 asphalt concrete base course, that's the hard paving grade 160, still the same. And polymer modified, I think this came from our SMA specification, again, still documented, declared by the producer. So the requirements haven't changed, but the way we need to read the specifications has. That's a problem for us. And the majority of hot and warm mix property performance requirements are now aligned, again, by product type. What did happen in the early days of warm mix is that the specification requirements were more rigid, more potentially difficult to achieve than their hot mix equivalents. But with the experience and the trials that were carried out, and with the belief and the approach to defaulting to warm mix, actually the product requirements, performance requirements for hot mix were amended to match those for warm mix where they were more challenging. So again, just a range of characteristics there: voyage content, wheel tracking, stiffness, and retained stiffness. That was an interesting maneuver, and I think it's a positive one. So as others have said already, forget hot and warm, it's asphalt, and these are the properties that we want to have in our asphalts. So that was binder course examples and some examples there for our new SMA spec. And the guidance note that's provided to justify all that is that the inclusion of both warm and hot mix options enables optimization of material selection compliant with the designs to suit site-specific constraints. That then allows the specifier, where they believe warm mix may struggle, that they can still specify hot mix where they need it, where they absolutely feel they need. That's the only way to meet the requirements for a specific site. So what does that mean in terms of performance? Again, from our video, all the research we've seen, we've read everything from across Europe, we've done trials in the UK. Everything is telling us is we get similar or actually improved performance to hot mix. And I think there was a question in the chat about long-term performance. One of the perceptions still to be proven is that lower mixing temperatures reduce your initial binder hardening, which should be beneficial for durability. What other performance benefits have we seen, or I think we're going to see? We heard earlier about shorter cooling times. So theoretically, we can get shorter work programs. We need less traffic management on the road. We can reduce costs of having traffic management out there and traffic delay. There's less disruption for road users, and the carriageway actually gets reopened faster for the same volume of material that goes in. Right, so that's the approach we've taken. What does that mean in terms of our production? I haven't got numbers as far back as Gare has, but in 2021, GB production of warm mix was estimated just over 1 million tonnes of 26 million tonnes total. So that was just 4.5% of total volumes in Great Britain. By the end of 2023, from a little survey I did amongst members, our members produced 6.5 million tonnes of warm mix from a total of 21.5 million tonnes, which is 30%. So in 2 years, we leapt from below 5 to around 30%. We'll give ourselves a round of applause there, but there is a caveat that that ranges from 3% up to 70% by the producer, depending on their warm mix production capacity. With over 250 plants in the UK, they can't all be changed overnight. They can't all have new systems and new suppliers embedded, but definitely the major companies are defaulting to warm mix across their product ranges. And again, we'd like to think that that was part of or a result of the major promotional push by industry. Myself and members going out doing presentations. As the association, we provided briefing notes and promo materials. Again, this is 2016, where we were talking about tomorrow's asphalt being here today. So again, nearly 10 years ago, warm mix was really still ready to go. And it's taken a long time to break the back of the market. What about challenges? Why are we struggling to produce 100% warm mix? Is there still a lack of producer confidence? Are some producers more willing still to trial and learn from others' mistakes as and when they might happen? As I indicated, there is a limit on the product types in the specification, and the highest confidence and evidence there is probably from the highest volume materials, because clearly you want to make the biggest impact on decarbonisation with the things you use the most. Interesting on this, that 80% of local highways authorities include warm mix in their specifications, but procure somewhat less. So we believe there's lower confidence in that sector of the market. So that 30% volume we're assuming is coming primarily from National Highways application because it's their specification. Local authorities have the flexibility to specify individually. A lot of them follow National Highways, but they still have that flexibility. And if there's low confidence, they're not going to specify it. They're not going to procure it. As I said, the primary driver was decarbonisation, but there's actually a difficulty in carbon saving. I know Ger sympathises here that the systems and methodologies to evaluate carbon from our products is not yet, let's say, fully formed. It's robust as it stands, but every time we look at it, there's always something needs changing, which then gives you difficulty challenging some of your assumptions and the data and the numbers that you generate. For example, using other people's data sets that you have to rely on. When you're evaluating the carbon footprint of asphalts, you have to trust the number you're given from the bitumen industry, your bitumen suppliers. And in the last 12 months, we've seen that more than double. So as an influence on the carbon footprint, it might not be the temperature that's the real issue. And to be fair, some temperature reductions are relatively modest. 20 degrees, you would feel it personally, but in terms of an asphalt, can you really feel the difference in 20 degrees? And then that leads into the user, the hand lay in particular, their physical perception of temperature. They've had long careers working with very hot products. Reducing that temperature to them has always been a sign of poor quality. if they get something cold, they generally don't like it. And we've seen those challenges expressed. It's down to how we measure that workability. So what are the challenges and what are the enablers? Perhaps for us in the UK, we need to expand the product types in the specification, but for that we need more evidence and confidence, which is more trials. Thankfully, National Highways do have some incentive funding through what they call low carbon demonstrator funds. We also need to expand the usage for all road types and all clients to encourage them to specify and procure, not just permit in a document somewhere in a contract. A lot of contracts are long term, so you almost have to wait 5 or 7 years before they change the contract to allow a different specification such as Warm Mix. We need to fully quantify, more reliably quantify our carbon savings so that we can compare to our baseline EPDs. We're working with tools that, again, recently just published a revised tool for carbon assessment in the UK. And already we can see the next generation of Warm Mix in cold mix. Can we reduce those temperatures further? Is Warm Mix a passing phase, and should we actually be concentrating on Warm Mix? And are the standards actually a blocker to that innovation? So what lessons have we learned and what recommendations? Again, borrowed from other presentations. As I said just then, standards are not a barrier as they're currently written, but specifications citing those standards might be a blocker. Generic technologies are available. In the UK, our clients have taken a very permissive approach. They don't define what method to use, and more are being developed, like pre-blended warm mix binders. And I can't remember who said it earlier, but why worry about how warm it is, what the actual temperature is? Think about using the same acronym of WMA, workability modified asphalt. I don't know if that's a light bulb moment for anyone, but we need to measure the workability more effectively, particularly on site. Temperature has been a reliable measure for decades, but it's the workability that we need to ensure as that quality measure. I use a comparison with concrete there. Globally, everyone's doing a slump test, and that tells you how workable it is. I believe we need something similar for asphalt. So again, I think some of these have been mentioned, recommendations. Everyone needs to take a collaborative approach on this. That's across industry, between companies, collaborative with our clients, road owners and operators. And we all need to listen to, act on the feedback that's coming back to us. So all that stuff that's coming from the hand lay gangs that they don't like it, we need to take that on board and work to improve it. Ideally, get some funding to support those sorts of developments. We need data-led evidence. We can't just scream and shout and say, this is the best thing, this is going to give you all of these additional benefits. Recently in the UK, a number of registers of projects, decarbonisation projects, have been developed, freely available online, so that clients can come in, look at what's worked, what hasn't worked from those registers. Don't fear failure. I'll put that in inverted commas because failure might be a learning point. I think everyone's said today there's been challenges, but they've driven that circle around to say, well, we got to that point, it didn't work, let's revisit and go back and let's take the next step. Use whatever leverage you do have, political, societal. So our key driver was decarbonisation, it's a key driver for society. We actually got good support through a group we work with in the UK Parliament, our parliamentary group on highways, who helped us produce and release effectively a statement from MPs in support of Warm Mix and why all roads clients in the UK should be using it. So a political lever there, which I believe helped us get that change in specification. And promote all of your benefits, regardless of what your key driver is. That's the one you focus on, that's the one you shout about first, but flag up everything else. So it's a holistic approach, stacking of the benefits. So as we said here, in 2016, Warm Mix Asphalt provides environmental, performance, and safety benefits. And end with the call to action to be business as usual, to make Warm Mix Asphalt use the norm rather than the exception. And if you want to catch up on that video, there's a little QR code for you. And I think that's mine finished, Breixo. Yep.
I like this concept of workability modified asphalt. It's still WMA, but maybe it makes sense to focus more on the workability as a proxy for quality than instead of the temperature, as we already commented before. All right, so I have now, like, let's say 10-15 minutes to explain what is going on in 6 different countries. So I will try to be as brief as possible to come back to the Q&A as soon as possible. I will try to share my screen. So excuse me if I go a bit fast at this point, but again, I think it's good to have a picture of what is going on in some other countries. So briefly, in 10-15 minutes, I will summarize what is going on in additional 6 countries in Europe. So starting with France. In France, there is a strong industry commitment and policy pressure to increase the use of Warm Mix Asphalt. In fact, there is an agreement between contractors, owners, and stakeholders in general to deploy, let's say, a massive amount of Warm Mix Asphalt in the coming years. The current goal is to produce 80% of regular asphalt below 150 degrees by 2030. And the main drivers for this decision is, of course, energy and emission savings. Also, the reduced fuel consumption became more attractive as fuel prices rose in recent years, as I explained before. And also we have environmental impact, reducing bitumen fumes emissions and improving air quality and workers' health and safety, understood from the point of view of less odors, smoke, risk of burns, heat stress, etc., etc. There are multiple techniques used in France. The main one is foaming. Also, they use additive technologies, especially chemical surfactants. And also this sequential mixing on double coating consists in a 2-stage process where a softer binder is first used to pre-coat the aggregates at a moderate temperature, followed by a second binder, often foamed bitumen, added at a lower temperature. So yeah, this sequence allows a good coating with still good workability without heating the mix so much. And sometimes it's common that actually the optimum solution is a combination of different things. So using some chemical additives in combination with foaming, etc. Regarding the application, compaction, etc., no special equipment is needed, and contractors use basically the same equipment with the same standards, etc. It is true that on projects where a significant portion is done by hand and in small batches, like patching and tight areas, some problems may happen because the mix heat cools down faster because of the small amount. And also that the recommendations right now of using Warm Mix Asphalt at less than 150 degrees is only recommended when the ambient temperature is more than 10 degrees, no rain, and the wind speed is less than 30 kilometers per hour. Although it is true that all these conditions are currently under discussion because, well, the recent developments are allowing actually to pave in worse conditions. Regarding the logistics, there are no major technological barriers at the moment, reported from France. And in fact, already by 2020, most of plants and producers already have at least one Warm Mix Asphalt process installed in the asphalt plant. So regarding the production, we have seen that some increase from the years 2009 and so to the years 2015. But then due to the lack of demand and incentives, we have some steady stage where the production, the market share, let's say, was around 10 to 12% of the total production. But then in 2021, with this agreement was signed, they experienced a big push for Warm Mix Asphalt, bringing the market or the share up to values of 24-25%. We have seen last year, however, a small decrease that we will have to continue monitoring what happens with this, if it's just something happened last year, but the trend will continue going up, because as I showed, this orange point up right is the objective for 2030. So we'll have to see if actually the trend continues going up really hard to find that to meet that objective. And it's also true that there are big variations depending on the regions, different inside France. There are some regions that in 2015 already have 45% of Warm Mix Asphalt production, and in 2020 some regions also have 80%. And this means that when the contracts actually specified Warm Mix Asphalt as the standard solution, and this is done in collaboration with the industry, etc., the target of 80% is feasible. So this is what it shows. Some challenges have been reported. For example, that the main struggle in France is not technical, but organizational and motivational. Despite the Warm Mix Asphalt is a proven technology and it has evident benefits, there are still conservative specifications and the mindset of continue using what we know that has been working for decades, right? And also we have technical constraints and exceptions. For example, although there is no fundamental technical barriers, a few mix types are trickier to produce with Warm Mix Asphalt. And likewise, in very cold and humid weather or long haul distances, hard bitumen, manual working might still need, we might still need to use some hot mix, is what they have reported. So some lessons learned and recommendations. First of all, industry commitment is a key enabler to continue working towards this goal. We need the companies being involved, competing, even have a stake, the reputation of the company. They need to catch up on these Warm Mix Asphalt technologies. We need clear definitions and standards to remove ambiguity for contracts and reporting, encourage the use of Warm Mix Asphalt via procurement and success stories. So also sharing stories that are successful can motivate others to use it more. Continue joint research and development efforts between technology and industry, because there is no single Warm Mix Asphalt technology that fits all the situations. So we have to continue finding out what is the optimum technology for each case. And monitor performance and share data to reduce skepticism about Warm Mix Asphalt and the concerns, for example, about rotting or moisture damage, durability in the long run, or environmental impacts. The next country is Spain, where actually Warm Mix Asphalt is considered as a mix that is produced at least 20 degrees Celsius lower than the equivalent hot mix asphalt. Nowadays, the main factor driving the use of Warm Mix Asphalt is the environmental requirements in construction tenders. And although they're not official figures, I would say that a large number of plants have been equipped with bitumen foaming, although there are also some producers that already have installed the equipment for the use of additives. No specific problems have been reported in job sites when using warm mixes, except for the loss of workability sometimes, which can be especially relevant when there is a lot of handwork on site. Still, no properly documented studies have been conducted on the density differential, so saying that the density at the end is lower. So we don't have evidence for that in Spain at the moment. Quality control of Warm Mix Asphalt obtained by foaming, it's a problem, and they have reported, as there is no laboratory equipment at the moment that can simulate manufacturing conditions in the plant. In practice, hot mix formulations are developed and manufactured using foaming technology with samples taken at the plant to verify its adequate performance. When we see the production, we don't see really a clear trend. It's more like a fluctuation of values of year productions between, let's say, 500,000 tons and 650,000 tons. And the challenges is that so far there's not really a pressure from the administration related, for example, to exposure to fumes, like is the case of Germany. And at the same time, there's no really significant economic advantages for the companies to do that. So this is why things are not moving so fast. But two main driving forces that have been identified by our Spanish colleagues are that if this health and safety legislation gets stricter, or for example, we have more regulations on emissions trading systems, which with penalties for CO2 emissions through taxes on non-renewable fuels, these kind of things will for sure increase the use of warm mix asphalt. The next country is Italy. In Italy, we have since December 2024 what is called the minimum environmental criteria for roads, where they have introduced the concept of warm mix asphalt in a very interesting way, I would say. So basically for urban roads and sections of extra urban roads located at less than 1,000 meters from residential areas, the maximum installation temperature is 120 for unmodified bitumen and 140 for when we have, for example, rubber or modified bitumen or polymeric compounds. Beyond 1,000 meters from residential areas, we can still use the temperatures 150 for unmodified bitumen and 165 for the other cases. Warm mix asphalt, all this applies to every type of mixes, from dense gray to porous asphalt, and must always guarantee the same performance as hot mix asphalt. The main drivers in Italy is reducing emissions in urban areas and reducing heat islands, which bring also other benefits that are appreciated, such as lower energy consumption and worker safety. Chemical additives are the main technology used at the moment. In the recent years have been also used these pre-modified bitumens that already come with the additives, but it's not really a technology that is growing so much because it lacks some flexibility to adapt to different cases and different situations. The testing methods are the same as those for hot mix asphalt, only the compaction temperatures of the laboratory specimens is added. And the latest generation of asphalt plants, they all are equipped with additive dosing systems, and for the others, metering pumps and so can be installed without any changes to other parts. The main challenges reported is that in Italian documents, solutions that increase service life and recycling are generally preferred. And itself, warm mix asphalt is not something that we do to extend the service life, or it has nothing to do with recycling. And this is why there's not such a strong push, I would say, at the moment. But recommendations that we have from them is that if an organization, public administration or contractor or so, is evaluating the inclusion of warm mix asphalt in its programs and policies, they recommend to consider both the benefits and the risks and critical issues. The potential advantages shall be verified using an LCA and compared with other technologies over the service life of the pavement. From Ireland, we have received information that warm mix asphalt is gaining rapid acceptance across the country with widespread capability among producers and growing specification by road authorities. In 2024, approximately 650,000 tons of warm mix asphalt were produced, and currently local authorities and county councils will require minimum 20-25% of asphalt being warm mix asphalt, and the Department of Transport has announced a target of 50% warm mix asphalt use in DOT works by 2026. Trials carried out with Transport Infrastructure Ireland, often in conjunction with Reclaim Asphalt pavement with RAP content, have shown significant reductions in CO2 emissions, and all monitor sites have performed satisfactorily to date. With a strong policy momentum and positive field performance, they believe that it's expected to become the warm mix asphalt the default asphalt type for base and binder coarse material for DOT and TII works in Ireland within the next few years. The key drivers we have been repeating is the same, so carbon reduction, energy savings, improved working conditions, regulatory and policy support, national and local authorities' encouragement under sustainability policies, and also the compatibility with, for example, circular economy, the use of RAP, and so on. There are some barriers identified from the specification restrictions, especially for certain mix types. We have additive cost and plant adaptation, conservative attitudes, risk aversion. We talked about this already before. Training needs for crews and inspections and inspectors needed. Climate and weather constraints we can have, and product that will cost more. However, we also can have enablers that can revert the situation. So policy push from the DOTs and TII, industry capability and plant readiness, proven trial performance, standard specification amendments, and RAP compatibility and sustainability drivers. Finally, they have sent some recommendations on what to do and what not to do for quality control. So it's important to control production and delivery temperatures precisely, use type testing and factory production control in line with EN standards, verify additive compatibility with binder, aggregates, and RAP, maintain proper compaction to achieve specified air voids and binder content, and don't allow excessive cooling or hold times without mitigation, for example, use of insulated trucks. And don't compromise on quality control or temperature monitoring, ensuring consistency of the product from plant to site. In Croatia, Warm Mix Asphalt has been included in the regulations recently and is understood as mixes manufactured at least 30 to 40 degrees lower than the equivalent hot mix asphalt. So it's similar to Spain, but even more ambitious. Energy consumption savings, CO2 emissions, and fumes exposure are the main drivers for introducing Warm Mix Asphalt. And there are no still fixed requirements in tenders or the same documentation which mandatorily requires the use of Warm Mix Asphalt. Bitumen foaming technology is mostly used, around 90% is foaming, but some special projects have used waxes. Equipment for paving is the same, but with adjustment in process of pavement. For example, overlaying thickness during paving must be 5% higher with Warm Mix Asphalt produced with foamed bitumen than with hot mix asphalt to achieve the same layer thickness. And also on compaction, we need some little modifications. The workability and stability of some types of mixtures is generally better in the mid-range of temperatures, and quality control processes are the same that hot mix asphalt. Health and safety requirements are met even more easily than with hot mix asphalt, so no problem in this regard. And at this moment, around 10% of all asphalt produced in Croatia is produced in Warm Mix Asphalt. Still, there is not any requirements for clients in tenders that promote or bonify production of Warm Mix Asphalt, so many smaller producers do not want to invest in this technology. Regulation regarding emissions are still not restrictive to promote Warm Mix Asphalt, but main game changer will be they will have more requests from the client for the administration in the next years, for example, related to the decrease of CO2 footprint and bonifications in tenders as part of green procurement, which was already announced by the government, by the way. And finally, I would like to present the case of Czech Republic, where until 2024, the use of Warm Mix Asphalt was practically marginal. But this was mainly because of the absence of demand from both administrations, was absolutely no bonus or bonification for the use of Warm Mix Asphalt compared to hot mix asphalt. In fact, there is the requirement of the Ministry of Transport for a certificate of product suitability, which at the moment no additive still have in the market. Also, there is no cost benefits for producers, etc. So this is why things didn't move. But in 2024, the national authority, let's say in Czech Republic, was aware of what was going on in other countries like Germany, France, the Netherlands, and they started moving some things on. So they announced in 2024 4 tenders for road rehabilitation works, which were treated as actually experimental sections to see what is going on there. So 2 job sites were carried out in 2024, 2 are being carried out in 2025, and every test section is being done by different companies and different technologies. So the experience that they get from these sites will be used by the administrations for the tendering in the future. Some monitoring will be done also on those sections. Also, the administration finalized this year a new instruction for tendering in case where these 4 defined technologies are used. And some bonuses will be allocated to these technologies in order to promote their use, actually. It is supposed that this instruction will be used by the administration then from the next year. And the reason why they are doing this is to follow the requirements of the public procurement law that they have in Czech Republic, aiming at motivating the public sector to leave these single criteria tenders, mainly based on costs, and include additional criteria, for example, related to environmental and social aspects. With this should establish a framework for broader implementation of these technologies in the road construction in Czechia and in the future. All right, so that's it. Apologize again for being a bit fast. I will stop sharing my screen. And with this, I think we can start some quick Q&A because we are out of time already. But I would like to bring back our speakers and maybe spend 10 minutes, 10, 15 minutes on some quick Q&A. Trying to find what questions we have at the moment. All right, are we all back? Still there?
Yep.
So first of all, I have to say that we have a massive amount of questions. Absolutely no chance to answer to all these with the time we have. We're already out of time. Maybe what we can do is to just filter a couple of questions for each of you, and then maybe afterwards we can work on a document where you can respond to this and we can share it with the participants. Anyway, we will make sure that all the questions are answered at some point. So retrieving now. Okay. So I have some questions for. So if I start with Knut. Knut, does the NINAS device that you mentioned provide good proof, especially in case of surfactants used in warm mix asphalt at reduced compaction production temperature?
Well, for the moment, it's the only one we really know. So I think it's better than nothing. What I've seen so far works quite well. So
right.
I'm not sure if it's the end of the story, but it's the way we're approaching it. So we have to start with it.
Yeah, in fact, this I can link this question to Malcolm. Malcolm and I, we are involved in SEN standardization committees. I remember like around a year ago that we brought on the table a proposal, should we start working on a test method to define the workability on site? If we are not going to, if the temperature is not the key KPI at the moment, then is the workability, how we can actually measure that? And the answers we got were a bit, I don't know, not, it was difficult. For example, in Belgium, I remember they have been trying to define a test method based on the area covered by the mix when it's spread on an area or on a surface. And France and Germany, for example, they were trying to use the funnel of the segregation index test to see if, for example, to measure the time necessary for the mix to get passed through the funnel, but the results were not very stable, was not clear. We've also this part 10 of EN 12697 series on compatibility, but somehow nothing seems to fit, right? I don't know, Malcolm, how do you see this? How we can really assess the workability?
Yeah, it's definitely a challenge, and given the vast range of product types and individual recipes that producers hold, trying to find one test that fits everything is going to be a massive challenge. I think the Belgian approach, they were looking initially at mastic asphalt, so you don't have all of the aggregate in there that may cause workability issues by themselves. So you're looking much more just the binder and fines combination. The compactability method to me is more of a segregation method, but I think the ideal is something that is reliable, fast, and cheap. I think that's what we all want from a good test method that tells us what we want and what we need to know, without having to calibrate it. I know the work that Gare did on workability with ergonometers on shovels and rakes and things, way too expensive, and it'll only give you a brief confirmation. So yeah, definitely I think is an increase. And I don't just say this for warm mix. We don't have that method for any asphalt, a reliable workability method.
Yes, true. All right, thank you. Knut, I have another question maybe for you. Is it possible, or how to produce warm mix asphalt with addition of 50% wrap by foam process on double drum asphalt mix plant without modification asphalt plant? Is that possible?
The short answer is yes. So It's a little bit more difficult, I think. So when you do warm mixes, you have to make sure 3 points. You have to make sure homogeneity, which is quite easy with foaming. In fact, as I explained, you have to take care for adhesion. That depends on a lot of things, especially on your stones, of course. And the last one is compactability and the workability. So, but in general, yes.
Okay, thank you. Tessa, I have a question for you related to noise-reducing pavement types. I don't know if you're specialized on that, but there is a question about how is Warm Mix Asphalt a solution also for this type of pavements and mixes?
Well, the noise-reducing asphalt mixtures present some complexity in this matter, as they are almost all of them modified with primary bitumen. And currently, there are some strong indications that these types of bitumen may eventually be phased out due to its negative impact on health, safety, and environmental effects, as well as challenges related to its use and reuse at lower temperature. While a few noise-reducing asphalt mixtures can be produced at lower temperatures, the assessment we did in the working group concluded that their level of maturity is still insufficient, and that there is a lack of availability from multiple suppliers to ensure a level playing field. And therefore, we, in this version of the guideline, we have to decide to continue noise-reducing asphalt mixtures to be produced as hot mix asphalt, which is why the corresponding boxes are all have been marked in red. But we hope that in the future, these can also turn green in any way, because in the Netherlands, noise-reducing asphalt is essential.
All right. And another question is, if the production is kept between 100 and 140 degrees, are the problems on mixing plants solved, especially risks of clogging by filter dust and condensed water? Do you know about that?
Yeah, about clogging, to be honest, to my knowledge, these problems do not occur, or at least not frequently enough that for me as a client, I hear any concerns from asphalt producers. So I cannot be honest to answer that, to be honest.
All right. Good. I wanted to ask you, as I said before, what was the feeling from the government when you heard about this challenging objective for 100% production from the industry?
Yeah, to be honest, I was genuinely thrilled by the announcement. It felt like a long-awaited breakthrough. And for years, we have been talking about the need to transform the sector, but like the real change often seemed to just out of reach. And hearing this first transition by phasing out hot mix asphalt and making warm mix asphalt the standard signaled a bold and necessary shift. And to me, it showed that we are finally taking our own responsibility and embrace innovation.
Excellent. Okay, thank you, Tessa. Geir, I have a couple of questions. Actually, there are a lot of questions for Geir.
Thanks.
The one that I think is interesting is if an asphalt plant currently producing hot mix asphalt decides to start producing warm mix asphalt, what process modifications are required and how long does the transition typically take?
Depending on the plant, depending on everything, but that's the thing. When you have a heated aggregate in the tower, and then you change from hot mix to warm mix, you get some time depending on the capacity and tower and everything. But the issue is that you have up and down with the temperature, and that will give you some advantage both with the hot mix and warm mix. So what you do, well, our company do 25 different ways, so I don't have the answer. And the other companies I've talked to for this presentation, they have another 25 plants. So actually, I can't say.
Yeah.
You have to check your asphalt plant and how the production is set up.
Right. To the question that I asked Knut, is it possible, do you also agree, is it possible to produce warm mix asphalt with 50% RAP by foaming process or on double drum asphalt mix plant modification? in the asphalt plant without modification of the asphalt plant? Yeah.
Actually, I didn't mention, but in Norway we haven't used that much wrap. So there is, I think it's only 4 or 5 asphalt plant with a parallel drum among those 60. So our experience is mainly of cold added wrap. But yes, it will be. So I agree with Knut.
And actually, I have a question, because we have seen these objectives from the Netherlands and Germany about this 100% from next year. But actually, Norway was one of the original countries and where Warm Mix Asphalt started increasing earlier. Do you have any objective as well in this regard?
Objectives for increasing, or it's an you have to train and talk about it and try, and you have to modify your production system, and you have to train your people and the plant operators and everything. So now the main thing is that I think at least 4 of the companies in Norway, they really push this not 100% maybe, but at least 90% Warm Mix Asphalt. So yeah.
Okay. Thank you, Geir. And finishing with Malcolm, there is a question. Do you have any comments regarding the performance difference between hot mix asphalt and warm mix asphalt? Which type will be more advantageous to use for toll roads or motorways?
I don't have any personal knowledge on the levels of performance, but the approach that was taken is that regardless of warm or hot, the performance requirement is the same. So we've seen the challenge. The performance requirements have increased to prove warm mix better. And in fact, we've aligned the hot mix requirements to the higher warm mix requirement. And on that, effectively, that approach is it's asphalt. The temperature you produce it and lay it at is irrelevant as long as it gives you the end performance. So whatever your end performance requirement is for whatever your traffic, your climate, and everything else is, that's what you have to achieve, and that's what you have to evidence in your CE marking and everything else. So you need to know your requirement, and then it's the industry's challenge to meet that requirement with its products.
Excellent. Thank you very much, Malcolm. We are already 20 minutes after the end, so I would like to wrap up this Q&A and this webinar with some notes that I have been taking during these discussions, and that will help us to define better what to do during the workshop in June. So something that I have seen is that we don't have consensus at the moment of how warm mix asphalt is defined. We have seen that some countries is below a certain temperature, some countries is a reduction compared to the equivalent hot mix asphalt. So I think that doesn't help even to compare what's going on in different countries, because they might be measuring different things. Also, for how long we will continue focusing on the temperature, if it's hot or if it's warm. This is something that it was highlighted by different speakers. Malcolm proposed this concept of workability modified asphalt instead of warm. And Knut just said, let's call it asphalt, right? Depending on the country, we also see that different preferred technologies. So in some countries it's clearly the additive, some countries is more the foaming, some countries is a combination. So it's also difficult but it's good because that helps to test more things. The countries that are ahead are showing that the transition involves many challenges, but at the same time, they are showing that the change is feasible. And the drivers are very similar: reduce emissions, fumes exposure, energy consumption, health and safety. I take from Tessa that the transition requires vision, collaboration, and bold action. It needs collective effort and committed enablers. Every step counts. Small victories build momentum towards full adoption, and experience gain sets up future transitions for success. Knut also said that yes, we have different enablers, but at the end, sometimes only policy and real demand from administrations can trigger the change. So, and we have also seen from other aspects. So if no demand happens, if no policy really happens, then the change is difficult. In any case, as Tessa said, an open, transparent interaction between all stakeholders is a must, and I think we all can agree on that. With Gary, we talked about having good skills and know-how is fundamental. Sometimes it looks like it's impossible, but with know-how, it is possible. And Malcolm, you said, do not fear the failure. So I think it's important. Some countries that they are more, the mindset is more towards the direction. The sooner we fail, the sooner we learn how to do it. Other countries are more conservative or assuming less risks. And in these countries, the change, of course, is going to be more challenging. I finish with 3 things. 1, remind you that on 11-12 June 2026, we will have in Vienna the ENE event, an event that we organize every 4 years together with EuroBitume. And the registration is open from today. We just opened the registration today. I don't know if we have a slide that we can show. Not the other one, about the ENE. There we go. So you can register already with this QR there, or have at least all the information about this event. This event will start on 11 June at around lunchtime. So during the morning, right before lunch, during 11, and the day before the afternoon, we will have a workshop to continue, a physical workshop to continue these discussions. As I said before, this is a 3-step initiative. So we will have this workshop where we will work in groups with activities, for brainstorming and everything to define the future steps to have an effective, an efficient, and a smooth transition towards Warm Mix Asphalt in Europe. So also, I think you can register already for that or get information, but more information about this event, the program, and so will be released soon. This will be, as I said, on 10th and 11th June 2026, also in Vienna, together with the ENE event. And finally, I would like to finish sharing a QR code. Let's see if we can see it on the screen. Because, well, first of all, if you're watching this you are on our YouTube channel on EAPA, so I encourage you to have a look at the rest of the content that we have there. We have video podcasts, shorts. We have other webinars. For example, 1 year ago, more or less, we had a webinar on digitalization that has more than 4,500 views at the moment, very successful. But we have also videos from the International Road Maintenance Day. We have a lot of videos, of course, of the other activities that we do. So have a look at that. And if you like the content, you will support the channel if you subscribe, like the content, comment, and engage basically with everything that you can find there. Also, there is a QR for you. Let's see if I can share it on the screen for your feedback. We will also be grateful if you could take a few minutes to provide some feedback about this webinar. This will also help us to have better webinars in the future. So thank you very much, everybody, for this, especially to the speakers for the excellent presentations, also to our communication team that has been working in the background a lot to make sure that everything went well. We'll try to make sure that all the questions are answered. And of course, thank you very much to the participants and the great number of registrations and participants that we had today. Thank you very much, and we'll see you in the next EAPA webinar. Bye now.